Alright, so welcome to the Digital Greenbelt certification program. So this structure of running a Greenbelt session is something I've launched recently. Before it was Lean Six Sigma Greenbelt certification, and I obviously want to include the digital aspect to the Lean Six Sigma Greenbelt certification, mainly because the world is turning into digital, right? And if you don't start understanding the digital technologies and how automations are done in processes, you will definitely go out of the crowd that is moving towards the digital transformation. um, so which is why I started training my students, or at least started giving some sort of an awareness on some of these technologies which they have to be aware if they are stepping into the process transformation kind of world. So from a process transformation perspective, as part of this Greenbelt certification program, Lean and Six Sigma is included, and digital, intelligent automation and data-driven technologies overview. And I will also give you some aspects around waterfall methodology of driving a project versus an agile way of driving a project. Okay, so let's start with an introduction. I think we already had a good round of introduction between two of us, but I'll quickly tell you what I've done in the past. Um, that's my LinkedIn profile. If you want to go ahead and explore, I'll share the slides with you later. Um, my key expertise is Lean Six Sigma, project management. I've done operations as well. I've managed a team of 60 to 70 people in procurement and supply chain operations. And currently I do a lot of consulting. So one specific role that I perform today is with a company called Hudson and Hayes. So this is a company, it's basically a consulting startup with one of my ex-colleagues based in the UK. So we started this 3 years ago, and it's going pretty well. We are able to acquire a few good clients, and mainly we focus on Lean Six Sigma and process automation transformations. And parallelly, I do run trainings whenever I find time. So I set up a YouTube channel called Digitalpages Global, and I'm working on a website, mostly planning to do a rebranding of the name to Digital Process. And this is more to share the knowledge that acquired in the past so many years, plus also build a group of following where I can learn from my students as well as share my knowledge, right? So that's pretty interesting. That's something I'm working on for a long term. Now, some of the companies that I worked previously was Genpact. I worked with IBM. I worked with Xerox. These are the three major corporates that I worked before, and I was lucky to serve some really great clients during that period. So GE was one of the clients that I've served for a very long period. Then I worked with JLR, Otis, which is a elevator manufacturing company, General Motors for some time, few assignments with British Gas, and currently I'm working on a project with a company called Syngenta. Um, Industries, automotive, aviation, IT, ITES, multiple industries that I've served. Okay, so that's about me. I think you've given me your introduction before, but I'll give you maybe about a minute, just to restate what you want to achieve by doing this course and where you're heading with respect to your career. Excellent. Very good. Okay, so now let's before I jump into the agenda, so I'll just give you a brief on what Digital Greenbelt training is all about. So there are three aspects that I'm going to cover part of this training. One is the traditional lean techniques. So I'll give you an overview about lean techniques and some practice sessions using some examples, and lean principles will be covered. 8 types of waste will be covered as part of this, some tools and techniques that is used in the lean, and I will provide you with X number of templates that might be very useful to you. And in Six Sigma, there will be a detailed study of Six Sigma methodology and how do you apply these methodologies and tools and techniques in your business. So we follow a methodology called DMAC, which stands for Define, Measure, Analyze, Improve and Control. And 80% of our course is going to cover the DMAC methodology, and then you will have a live case study. So as in when you progress and study about these theory and tools, we will also work through a case study, a very simple case study which you can understand, and you will learn how to apply these techniques. And then I'll share you a list of templates, at least 20 to 25 different data files which you can use to practice. And there is a statistical tool that we usually train people for Six Sigma, that's called Minitab. There is a free version available for about 30 days for your training, which we can use, but I'm trying to minimize the use of Minitab, even though I'll give you an overview and how to use it. I've prepared a lot of Excel templates which can probably work as an alternate for Minitab in some cases, but not for complex analysis. We definitely need Minitab. And then in the Greenbelts trainings, I'll give you an introduction to process intelligent automation technologies. So some basic overview and what are the different technologies involved in IA. When I say IA, it is intelligent automation. And RPA is one of the most prominent technology out of IA that is being used in process transformation. So RPA stands for robotic process automation. And I will tell you what process mining and some data analytics, that's an extended learning which you can probably put it in your career map, or for the next couple of years, right? So once you pass through this stage, you can add process mining and data analytics to you, and thus you can grow into this career very well. Okay, good. Now once you complete the training with me, I'll give you an opportunity for testing and certification with a company called or a certification body called Six Sigma University. They are a US based university, not very popular, but a certification is a certification which you can use. It doesn't come with, there's no additional cost. I've included that as part of the certification program itself. Now apart from this, if you think you have you need a global globally recognized certification, then you can go ahead and write an exam with ASQ, which will cost you around 25,000 to 30,000 rupees just for the exam, and a similar exam called IASSC, which is called ISAC. That's again a Lean Six Sigma certification that's globally accepted. Both has an additional fee that you have to pay, and this course is pretty much aligned for you to go and pass for ASQ and ISAC, but requires a little bit of preparation. For any competitive exams, right, you'll have to prepare with you'll have to spend at least a couple of months reading through different types of questions, objective questions and stuff like that, right? So I'll give you at least 5 different question papers if you really want to prepare for this. Yeah, but I think if you get the first level of certification, that's good enough for you to go and apply for a job and showcase your skills and learnings, which is good. And I am going to do some collaborative sessions through this program. We use a tool called Mural. Mural is a collaborative brainstorming tool that we currently use, and it's been very useful to me, especially when the work from home, this remote working setup has started. I will give you an overview on that, and we'll do some sessions on that based on that. I actually wanted to include a few more guys into this training. I tried, and most of them are not available for the morning session. They're all signing. Yeah, and they all want the weekend sessions, and currently I have a weekend batch running, so I'll have to put them for the next level. One guy actually agreed, and he said he will try to join today, but I haven't heard from him, so I'm not sure. That's fine. Let's continue. If I get more people, I'll get them added to the batch. No problem. Okay. Now, any questions to me? Do you understand? Okay, brilliant. Okay, so today we are going to look at section 1, which is organization-wide planning and deployment. I will give you some basic fundamentals about Six Sigma and lean methodologies. What's the leadership roles and responsibilities in deploying Lean Six Sigma and lean methodologies, and how do you select a Six Sigma project, and what's the relationship between business systems and processes, and a little bit about the various stakeholders might be involved in these sort of projects. Okay, so now let's start with Six Sigma. Six Sigma is a management philosophy. It's a very structured and data driven approach to deliver improved customer quality, and it's a measurement of product and process capability, and the goal of Six Sigma is to attain less than 3.4 defects per million opportunities. I know there are lots of technical terms here which probably for you to understand, so always keep this in mind. It's a philosophy, it's a management philosophy. So somebody has developed a philosophy which worked very well for a lot of organizations, and it's very structured, and data is a key aspect for Six Sigma, and the key focus is always about customer quality, right? So anything that we sell to our customers, so whether it is a product, whether it is a service, customers expect some level of quality for that service that they are paying for, right? Let's say you're selling a mobile phone. The person who's buying a mobile phone will look for certain level of quality, right? If I want a superior quality, then I will go and buy an iPhone. But I want a value for the money that I'm paying, but I'm not really concerned about high quality, then I would go for an Android, basic Samsung, or any other phone that I can buy. But for a customer, for them, value is very unique, and they're expecting certain value. Now Six Sigma basically looks at those values and creates certain parameters called quality parameters, and then they try to improve that quality. Okay, we'll come back to all that. And then Six Sigma is more of a measurement which can basically measure any processes or product at the same scale. For example, you're working for a restaurant, right? So restaurant has a list of processes. You're working for an airlines company. An airlines company has a list of processes. Both are completely different, right? It's almost incomparable. We cannot really compare them. But with the Six Sigma as a unit of measurement, we can compare and say a restaurant process of a particular restaurant is working much better than an airlines company called Air India, right? So it gives you that sort of a measurement capability. We'll talk about that. Now, the goal of Six Sigma is to basically attain less than 3.4 defects per million opportunities. So if you're working in an airlines, if your flight is flying 1 million times, right, only 3.4 of that 1 million flights will fail. Okay, so that's the level of perfection Six Sigma basically trying to attain. We'll come back to that. Now, sorry. Six Sigma, in most of the organizations, when you apply for a job, they have different levels, right? And certifications are also different. Now, Yellow Belt is basically gives you a foundation into a Six Sigma methodology and tools. And if you are working already in a process, Six Sigma Yellow Belt gives you a, the basic push to apply these tools into your current work scope. And mostly you will end up supporting the operational and quality management teams or process excellence teams with Yellow Belt certification. Now the next level is a Green Belt certification. Green Belt certification, you actually learn in detail about Six Sigma tools and methodology, and you can independently apply these methodologies and projects within your work scope, and you might need some sort of a mentoring obviously from a senior folk who is called a black belt. A black belt will basically lead multiple Six Sigma project. So Green Belt, what they do, they only apply it to their work scope. Black Belt will basically do the mentoring of multiple Green Belt projects. Okay, and they basically train people. They act as a cultural change agent of Six Sigma. Master Black Belt is someone who has the approving authority of the Green Belt and Black Belt projects. They are mostly like a champion who owns an entire portfolio. Okay, so if I look at a Black Belt and a Master Black Belt are full-time roles in Six Sigma. So a Black Belt might be handling 200 to 300 operational full-time resources. Okay, a Master Black Belt might have a portfolio of 500 to 600 people reporting into them. Not a direct reportee, they are more of driving quality for the processes. Okay, so these are the key roles, right? For example, if you are completing your training today, you should look for anything that suits a Green Belt level of role within a process. So you might be an assistant to a process excellence manager, or you might be an assistant to a Black Belt in an organization, or you might be working aside a director of service delivery as a supporting associate or a assistant manager sort of a level, reporting into someone who is handling a leadership position. Okay, now Six Sigma obviously comes with some advantages apart from these structured approach to problem solving. It improves your eye for detail, right? So anything that you look at going forward, you will start looking with an eye of detail, right? You'll start analyzing this much better way, and your communication would definitely improve. The way you would present something back to the leadership once you learn these sort of techniques, that will completely change. Your strategic thinking will improve. Change management is a key aspect, right? So any change that you're doing to an organization, right? So every time you pick up a project in Six Sigma, using tools is one, but you will have to make sure the solution that you are putting across is very effective. It has to be implemented and somebody has to use it. Then only we can say that this is a very effective thing that you did. In order for you to do that, you have to do a lot of change management. How do you do changes in an organization? You have to make sure the stakeholders who is related to this particular area of business that you're improving should accept your solution, and they should support your solution. They should be willing to implement the solution. Okay, so that requires lots of leadership and influencing skills and lots of change management skills. We will talk about this later. All right, any questions? Good stuff. Okay, now let's look at the history of Six Sigma. So Motorola, in the late 1970s, they were experimenting with problem solving and statistical analysis. Now Motorola was going through lots of operational challenges, and there was a guy called Bill Smith along with a team of engineers. They put together some tools and techniques which is already used traditionally in the manufacturing world by lots of engineers. They combined all these together, and they created a program called Six Sigma program. So that they launched in 1987 as an official program within Motorola. And GE, in 1996, Jack Welch was the CEO back then. He looked at the Six Sigma program, and he has seen the sort of impact Six Sigma is having within Motorola. He decided to implement this at a global level, and he made sure that Greenbelt certification has become a mandatory certification for anyone to get a promotion. So when I joined Genpact, it was actually GE back then. Okay, so when I joined, it was GE, and in order for me to become an assistant manager during that period, I had to complete a Greenbelt certification program. And then GE adapted it quite well, and followed by companies like Allied Signals, which is Honeywell now, Texas Instruments, IBM, then US Army, and today if you look at companies like Amazon or Flipkart, they all use Six Sigma and process excellent techniques that was used traditionally. Now there is lots of criticism also for Six Sigma. Some people have a different view, right? So they think Six Sigma is more of a consulting mantra, which is not very effective, because company like GE, even though they were successful for a very long period, now GE is not doing very good, and they're blaming it on Six Sigma and those traditional methodologies that's been used. But if I actually look at it, Six Sigma for an individual gives a lot of power and strength, right? It improves us completely as an individual. But the only mistakes some companies, the traditional companies, what they did, GE is such a big manufacturing company, right? They manufacture products like aircraft engines, turbines, oil and gas equipments. Everything is high capital oriented business, right? And the business has eventually evolved. Currently you look at the trending, the companies who actually make money like Google, right? They're all based on technology which is data driven. Now some of these companies who are very successful in the initial stages, they didn't quite adapt to the data driven technologies, which is what happened to companies like GE. But currently, with the DNA of Lean Six Sigma and understanding the digital technologies and data driven technologies, your career definitely gets a different level of push, which is what the modern companies like Amazon or Flipkart or Apple sort of companies do today. Okay, good. Now let's look at the timeline. The control chart was the initial way of analyzing a particular process, which was introduced by Walter Shewhart. He was a quality guru. He introduced this in 1924. Then Motorola introduced Six Sigma in 1987. Allied Signal adopted this in 1992. General Electric in 1995, and 2002 onwards, all big companies started. Lean timeline. We will talk about Lean in some time, but Lean is more of a very simple way of thinking, right? So more than any tools or technique or data or statistical analysis, it's a simple way of thinking, right? How do you go lean, right? So when I say lean, literally, which means if I'm overweight today, right, which means I have lots of fat in my body, I overeat, I follow a very poor lifestyle, which made me fat. And how do I become lean? I have to cut down all the waste as possible, right? So there is lots of fat which is a waste, which is creating issue. I have to cut it down. I have to avoid all the unwanted lifestyle that I'm having today, right? Probably eating late dinner. drinking a lot of alcohol, or smoking. So these are dangerous stuff that I need to eliminate, right? Something that I need to eliminate. And being more organized, all right? So create a simple schedule. So wake up in the morning at 6 o'clock, freshen up and do an exercise for 1 hour, have a lunch at 12:30, have your dinner at 6 p.m. and then don't eat anything after 6 p.m. and keep a structured, systematic schedule and follow it consistently, and every day look for ways to improve it, right? For example, if some of us go through different financial sort of issues, but we never analyze where we're spending our money, right? So if we go back and look and we take a list of area where we are spending money, and every day if you bring small improvements, right? So instead of eating out 4 days in a week, I cut it down to maybe 2 days in a week, right? So every day consistently improving. Now how do I come to that 2 days of only eating out? How do I plan for the next 5 days? Then when I get my off, I need to be really prepared, right? I need to organize the things that I want to buy. I need to organize how easily I can prepare a nutritious meal for myself, right? Instead of doing that traditional way of getting into kitchen and spending 2 hours to make a meal. So this sort of small improvements is what lean is all about, keeping things simple. Now Henry Ford implemented their new assembly line for the Ford manufacturing in 1910, which was probably one of the biggest evolution or revolution that's happened during that period. And then Toyota production system was implemented in 1950s and 1960s. Toyota went through huge amount of transformation within their organization, and they focused clearly on lean principles, and they've been very successful. Even today they are one of the biggest sellers of the cars. Okay, and James Womack was another philosopher who put together a program for lean methodologies in 2002, so he set up an institute to train everyone. Alright, so we'll come back to all that eventually. So let's look at the definition of Six Sigma. So the Six Sigma, in that sigma stands for standard deviation. Okay, so which is nothing but a spread from the average of any process or a procedure. I hope you understand what an average is, right? Right, so if you have 10 numbers, you just add all those 10 numbers, divide by 10, you get something called an average. Now you have an average value, and from average value, how all the other 9 values are spread, right? For example, if my average is 20 as an example, right? If one digit is 120, another digit is 10, right? So 120 minus 10, that's a huge spread that we are talking about. I'll come back to that with certain examples, right? So sigma basically represents the variation within a process, a spread. Okay, I'll give you an example. So now, in order for you to measure that spread with any process, we relate this to something called a Z value. That's a metric that indicates how well the process is performing. So when you have more number of defects in a process, then your Z capability will be low. When your defects reduce, your Z capability or sigma Z capability would improve. Okay, so to give you some examples here. Okay, so for example, if your process has 308k defects in 1 million opportunity, right? So you are manufacturing 1 million water bottles, and out of that 308k has been damaged or failed in production, then your process is operating at a 2 sigma level. So that's your Z score. Now if you reduce your defects to 66,000 out of 1 million products that you're manufacturing, your process will improve to 3 sigma. If you reduce that to 6,000 defects, then your process is improving to 4 sigma. If you bring it down to 233 in 1 million, then it's 5 sigma process. Only when your defects level is just 3.4 for 1 million, then you can call your process as a 6 sigma. And it's a way of calculating, which is why it's called 6 sigma. 6 sigma means almost no defect. Okay, now let's look at variation, right? So I was talking about variation a little earlier. Let's look at it. I'll start from the bottom right picture. Now you see this on the dartboards, you see, right, at a particular target, right? So if you are given 6 arrows to throw right into the dartboard, right, on the target, you manage to throw it on all these black spots that you see here, right? Now if I look at my target was that, right at the center, the small red circle which is right at the center, that was my target. Now my 6 shots are basically far away from my target, so I have a low accuracy. My accuracy has been pretty low, and I also have a low precision. Precision basically stands for how consistently are you able to perform, right? So consistently towards a specific point. Accuracy is how close are you to the target. So if I look at the second diagram here, the bottom one, left side, here again my 6 shots has fallen away from the target, so my accuracy is pretty low, but I have something called a precision. I'm consistently performing at a single point. So the process I'm following to throw, or the action that I'm using for the throw, is consistent. Only thing is it's away from the target. Now if you look at the second diagram from the top, which is low precision and high accuracy, it is almost around the target, but the precision is pretty low, right? It's pretty close to the target. My accuracy is not bad, but there is lack of precision. But in the first diagram, there is high precision and high accuracy. Now for a customer, anything that you are delivering or providing or manufacturing, they always look for accuracy, they always look for precision. Okay, so we understood variation, we understood accuracy, we understood what precision is, we understood what target is. Yeah, clear? Okay, now let me ask you a question. As a customer, let's say I'm sure you eat pizza, right? When I go to order a pizza, right, on an average I get my pizza within 20 minutes on an average. Sometimes they make the pizza and give it to us in 30 to 35 minutes. Sometimes it is 10 minutes, right? Or sometimes they give it maybe little earlier than 10 minutes also, depending on the crowd. Now as a customer, what would be your level of expectations when you walk into that pizza shop? Timing alone, yeah. So you're saying between 15 to 20 minutes. So here we are talking about two things, right? One is precision, and we are talking also about accuracy, right? But for a person who's supervising that pizza shop, he will be measuring, in most of the times he will be taking an average to see how my performance is. So let's say he takes a report by end of the day, and he delivered, let's say, 500 pizzas on that particular day. He took an average, and that average is showing up to be 20 minutes. And what was your expectation? 15 to 20 minutes. So according to him, his customers are happy, according to him, because his average is 20 minutes and the customer expectation was 15 to 20 minutes. But what he didn't realize is there are some customers who's been receiving at 35 to 40 minutes also. Some customers who are actually expecting in 20 minutes, but they were receiving in 8 minutes also. Okay, so that is also a defect. You know why that's a defect? Because sometimes as a customer I don't expect anything to come to me earlier, right? So let's say I'm going through a training, I'm conducting a training now. I'm going to break for lunch at 1:15. So what I did exactly at because I know on average it takes about 25 minutes to get my pizza. So I placed my order maybe around 12:55. I placed, or maybe let's say 12:45 I placed an order saying that by 1:10 or 1:15 I'll get my pizza delivered. But that day what happened, my pizza was ready within 10 minutes. So the pizza came off at 12:55 itself. I still have another 20 minutes to break for my lunch. So by the time I go and have my lunch, my pizza is already cold. I am not in a good thing to eat, right? Now, so this time I said okay. So next week again I am doing the same training. So what I realized, okay, these guys are actually delivering a bit earlier. So let me not order at 12:45. So let me order this at 1:05, right? 5 minutes past 1. Thinking he'll get it by 1:15, or maybe he orders at 1. But on that particular day, his pizza took 35 minutes or 40 minutes. And it reached much later than his actual planned lunchtime, right? Now, according to the supervisor of the pizza shop, he's not really noticing what's happening with the customer there. He's only worried about the average performance by end of the day, right? Now, what Six Sigma teaches you is to look at the variation of your performance and measuring where do we have the defects. So if I might have unsatisfied customers before by delivering early something or by delivering late also. So Six Sigma basically measures that sort of a variation in the process. Okay, now let's look at this using a diagram. Okay, so there are two things here, right? LSL and USL. It basically stands for specification level. So lower specification level and upper specification level. So you told me 15 to 20 minutes, right? So if I consider my lower specification limit as 15 minutes and upper specification limit as 20 minutes. So I don't want anything before 15 minutes. I don't want anything after 20 minutes. Okay. So when I look at my performance for the last, 10 times I ordered pizza with this particular shop, and I put this in a simple distribution graph, and anything that is delivered before this LSL is a defect, which is marked here in red color. So I don't see any deliveries that happened after 20 minutes. So there is no defects on this side. But my target, okay, so let's say my target was 17 minutes. That was my target. Something in between I'm keeping. And majority of my orders have actually delivered before that. So maybe they're delivering much earlier than that 15 minutes. So I have a problem here. My target and the actual average delivery is different. The average is around 12 minutes and my target was 17 minutes. So there is a difference. So in this particular scenario, what would you do? You want to make sure your performance, average performance, you're bringing it close to the target. Okay, so that's process of target. Second scenario, this bell curve is basically my performance and the average and target are the same. Okay, so I'm getting my pizzas in 17 minutes, I'm delivering my pizzas in 17 minutes, and that was my target too. But there is so much of variation. So I see a lot of pizzas being delivered before 15 minutes, a lot of pizzas being delivered beyond 20 minutes, right? So that's some area that I need to work on. That's a defect. Okay, so I need to work on centering the process in the first scenario, fixing the spread of the process in the second scenario. An ideal process would be staying within your lower specification and upper specification limit and meeting the target as well. Is that clear? Any questions? Okay. I converted this into Google slide and alignment is all messed up. Okay. So the key objective of Six Sigma project are basically looking at three things. One is centering the process, reducing the spread, and thus reducing the defects in a process. Okay, so let me give you some examples of how a classical view of quality, right? When some people say, okay, we are 99% of the time we are doing good, but 99% is only 3.8 sigma. Only when I say 99.99966% good, then I can say I am performing at a 6 sigma level. Okay, few examples. If you are 99% good, you will have 20,000 lost articles of mail per 1 hour. Sorry, my presentation is all messed up. I did some conversion in the morning. Okay, so if you have 20,000 lost articles of mail per hour when you are performing at a 99%, but which is 3.8 sigma, but it's a 6 sigma performance, you'll only have 7 lost articles of mail per 1 hour. 15 minutes of each day of unsafe drinking water if 99%, then 1 minute every 7 months of unsafe drinking water. 5,000 incorrect surgical operations per week, 1.7 incorrect surgical operations per week. This is a very critical process. You cannot have 5,000 incorrect surgical operations, right? So there is no way I'm going to say 99% of my surgeries are successful. So as a doctor, I can never say that. 2 short or long landings at most of the major airports daily compared to 1 short or long landings at most airports. So as an airline company, I cannot go and advertise saying that we have landed 99% of our flights safely. That 1% can be very costly, right? Similarly, 200,000 wrong drug prescriptions in each year, 68 wrong prescription every year. 7 hours without electricity each month compared to 1 hour without electricity every 34 years. Alright, so that's all about some basics about Six Sigma. Let's look at Lean now. Lean is a set of management practices. We basically focus on improving efficiency and effectiveness by eliminating something called waste. The core principle of Lean is to reduce and eliminate non-value adding activities. Emphasis getting the right things to the right place at the right time in the right quantity to achieve the perfect sustainable workflow. Okay, so few things here. We focus on something called waste. We eliminate waste, and we eliminate something called non-value adding activities. Okay, so what is a non-value adding activity? So any activity that customer does not pay for, okay, that's a non-value adding activity, right? For example, let's say you're working for a car manufacturing company, right? So a customer is walking in who's paying for the car, right? They're basically paying, let's say, 10 lakhs for a car. What do they get for the 10 lakhs? If I look at material by material, right? They get an engine, they get the body of the car, they get 4 tires, they get interiors, they get the lights, they get wires, fittings and everything, right? So anything that physically the customer receives is what the customer is paying for. Now let's look at behind the scenes. In order to make this car delivered to the customer, there are thousands of activities that we do at the factory level, right? So there is lots of waiting time we will have to perform in order to get the materials in. We have to make hundreds of calls to the suppliers to bring the raw materials in, and sometimes while working on particular material it has a defect and it is sent back to repair, so that repairing activity. um, so like this, hundreds of activities that they do, but that is something customer don't really pay for. End of the day, customer is only paying for what is delivered to them. So any work that you do on a specific product that you're delivering to the customer, where you're making changes to that final product, that's called a value adding activity. Any activity that you do but you don't make any changes to that final product, then that's a non-value adding activities. I'll come back to this with an example with the video. Okay, so for now, just understand that much. And then in lean, we always try to do the right things and deliver it to the right place and at the right time and in the right quantity. Okay, good. So I talked about value add time and non-value add time. In majority of the process, right, 95% of the activities that you do in majority of the work are non-value added activity. We cannot eliminate them completely, but we can minimize them, because some of these are essential, right? In order to procure a material, even though that's not a value added activity, but that's an essential activity for us to perform. So we cannot completely eliminate. We can only think about ways to reduce the number of days that we take to procure some material from a supplier. Okay, so we minimize it as much as possible, and by minimizing it, we can reduce cost, we can reduce defect, we can reduce lead time, we can reduce inventory, we can reduce the space that we are utilizing, we can reduce lots of waste. So by reducing all this, what happens? You improve your productivity, you improve your customer satisfaction, you make a significant increase in the profit, your capacity will increase, your quality will improve, cash flow will improve, on-time delivery will improve, your employee morale will improve, your safe work, and you will have a safe workplace environment to work. Take few minutes and just think about these specific points. Okay. Let's say by improving a process, how do you think it will improve the employee morale? Can you think of an example? By reducing some sort of a waste, how can you improve the employee morale? Let's say there is a significant waiting time at a hotel counter, right? So you take the bill, you get the billing done, and then you go to the kitchen and wait for your food to be delivered. Let's say it's a self-service sort of a scenario. Now, the more and more employees come and wait there, more and more customers come and wait there, the employees will be under so much of pressure. There will be so much of shoutings, people asking you to hurry up, so if you are able to improve your process in such a way that as soon as the customers come and do the billing, the orders get processed, it's assembled faster, and it's being delivered to the customer within a specific time period which customer is expecting to be waiting, right? Then that will reduce the stress level of an employee. Let's think about another example of a capacity. How do you think the capacity can be improved? Yeah, let's talk about space. So let's say, if you worked in the IT or ITES companies 10 years back, right? Everyone had a dedicated seating, right? Everyone had dedicated seating. So as soon as I'm onboarded into a company, I'm given a certain workspace, right? So 24/7 that workspace is mine. So I go and put my God's picture, and I put my tables, I took my printouts, I keep my gifts and everything in that particular workspace. Then as and when the business started growing, there was a need for the companies to buy more workspace, right? So that increased their real estate cost significantly. Now, one of the improvements what they did during that period was they did something called seat utilization. So in seat, yeah, so in seat utilization, what they did a mapping of their employees who are working in that particular company, and they looked at their shift timings. So there is a team that works in the morning, there's a team that works in the evening. Okay. Now what they did a seat utilization. Morning, one particular team can use that workstation. Evening, by 6 o'clock, you have to leave that workstation for the evening people who are coming to use that. So everything is shared. So that's a significant improvement that they did. Okay, so that's how you improve the capacity. And at the same time, you can increase the capacity within the resources itself by freeing them from some of the transactional tasks, right? For example, by implementing robotic process automation, where a lot of these transaction activities can be automated, which basically provides them a bigger capacity to take up strategic sort of work. So in the initial days, we did a lot of macros, if you remember, right? If somebody was working on Excels, we created lots of macros using SQLs and DBA and all this stuff, and they saved a lot of time. Yeah, that's capacity. Profit, any wastage that you avoid, right? That improves the profit. Good. So we will come back to all that with examples later. Any other questions from what we discussed so far? Good question. Good question. So just give me a minute. I'm trying to activate one of my. Just give me a minute. I'm just pulling out a tool. Sorry, I'm just trying to. There's one particular tool that I usually use for me. Okay, forget it. I'll fix that for the next class. But let me just explain it with an example here. I basically use a tool to draw all this on the presentation itself. That tool has gone missing and everything got uninstalled. Okay. So let's say I'll take the simple example of a car, right? Let's say what you do as a customer when you are trying to buy a car, you are going and placing an order, so doing the booking. Okay, so you do the booking, and then the assembly happens, and then you have the paperwork. I'm just making it very simple. Okay, so let's say you are going to a car manufacturer which has huge demand. Okay, so let's say they say there is about 30 days is the waiting period. 30 days is the waiting period for doing this car. So within that 30 days, so your booking will happen, your assembly will happen, paper will happen, and you will get your car. So your lead time is basically 30 days, which is the end to end overall. But when I say cycle time is the time that is actually being utilized for building a particular car. So it could be just the assembly time. Okay, for example, there is 100 orders that come to this particular assembly unit. Okay, and they take about, let's say, 2 days average for manufacturing one particular car end to end. So that 2 days is basically the cycle time. Okay, so how do they calculate that 2 days? So they look at 100 orders that is being manufactured on that particular month with X number of employees, X number of resources. So based on this, they do a calculation saying that, okay, on an average for each car end to end assembly, it takes about 2 days. That's the cycle time. Okay, so my cycle time is only 2 days, but the overall lead time for the customer is 30 days, because there are a lot of things involved, right? So there might be waiting time, right, that is involved. Maybe only one car gets assembled at a time. So if you already have 100 orders waiting here, yours will be the 100th car that is being picked, right? So you have to wait for that 99 cars to be completing the assembly production so that your 100th car is being picked. So all that is included in the lead time. And then there is paperwork, and there is a lot of other things that you do. I have a couple of videos to showcase on how does it explain, and there are a few examples on how do you calculate it. I'll come back to that. Okay, good question. Anything else from here? Sorry, let me just. Yeah, this is the overall cycle time. Your cycle time will significantly reduce in the after stage.